Hey everyone, and welcome back to The Explainer. Okay, let's jump right into things today. We're focusing our attention on Lesson 5, Security Gates and Evidence-Based Promotion. We're going to map out exactly how you can build a highly secure, literally impenetrable MLOps pipeline. Because, if you've been following along with our series, you already know that deploying machine learning models isn't just about getting the math right, is it? It's about getting the engineering and the security absolutely flawless. So today we are going to transform your pipeline into a high-security cloud facility. Let's get into it.
So let me ask you a question. What do you think is the absolute biggest risk in a multi-environment MLOps platform? I mean, you might naturally think it's deploying a model with bad quality or maybe a poorly tuned hyperparameter, right? Actually, scratch that. The single highest risk is the uncontrolled promotion of models between trust zones. Think about it. If a model can somehow slip from a low-trust experimentation environment straight into a highly sensitive production environment without strict checks, well, your entire system is vulnerable. It's a massive risk.
To fix this, here is our roadmap for today. First, we'll cover the fail-closed philosophy. Then we'll walk through our 4 mandatory security gates: securing the build, the automated fortress, the dress rehearsal, and continuous operations. And finally, we'll wrap up with the ultimate authority, the human element.
All right, starting with part 1, the fail-closed philosophy.
The absolutely crucial thing to understand here is this fail-closed design mindset. I want you to think of this like a high-security badge scanner at a top-secret facility. By default, that door is locked. Movement is completely blocked, period. The door is only going to open if 3 very specific things happen. The exact mandatory security checks pass, undeniable cryptographic evidence is produced, and explicit approval is granted. There is no silent bypass here. If a check fails, the pipeline fails closed, and that model goes nowhere.
When you look at how this philosophy maps out across a multi-account AWS structure, it's pretty revealing. The path isn't just a casual hop from a notebook to a pipeline to an endpoint. It is a journey. You're moving from low-trust zones, like experimentation, and deliberately stepping into the highest trust zone, production. Every single boundary between these zones acts as a hard, blockable security gate. They aren't just polite handoffs. They demand hard evidence and approvals at every single step of the way.
Moving on to part 2, Gate 1, securing the build. Look, experimentation is intentionally flexible. Data scientists absolutely need room to explore, and honestly, that usually results in some chaotic, messy notebooks. We've all been there. But SG1 forces a major cleanup. To pass this first gate, you have to refactor that ad hoc logic into industrialized, version-controlled pipeline code. We also run mandatory secret scanning right here to ensure absolutely no API keys or credentials are accidentally leaked into the codebase. And critically, we separate interactive IAM roles, the permissions a human uses to click around, from the automated build roles. Bottom line, only governed, repeatable artifacts make it through this first door.
All right, part 3, Gate 2, the automated fortress.
Now, because the dev environment is essentially your software factory zone, SG2 requires some heavy automated evidence. To clear this checkpoint, the CI pipeline must pass entirely. You're going to have to generate a software bill of materials, an SBOM, detailing every single dependency. You've got to cryptographically sign your artifacts. To prove their provenance and authenticity, you have to pass static application security testing and container scans. And of course, the whole shebang. The model itself must meet predefined mathematical evaluation thresholds. If any of these automated scanners detect even a slight issue, boom, the fail-closed perimeter slams shut.
Next up, part 4, Gate 3, the dress rehearsal.
To really understand SG3, you just have to compare pre-prod directly to production. Pre-prod is deliberately designed as a high-trust, low-flexibility mirror of your actual production environment. Its entire purpose in life is to be the last safe place to fail. In pre-prod, we are using integration tests and stress tests in an isolated setting to safely break the model before it ever touches production, because out there it would impact live inference, real customer payloads, and your critical business operations.
So to actually get the green light at SG3, your model must survive some truly rigorous resilience tests. But it's not just about the model passing a math test, it's about operational readiness. You have to validate your runtime IAM and network baselines, making sure things like VPC peering and least privilege are completely intact. You must have all your CloudWatch monitoring and alerting fully configured. And crucially, you absolutely cannot pass this checkpoint without a concrete rollback or canary deployment plan ready to execute. Production only gets what is tested, approved, and shielded by runtime guardrails. No exceptions.
Moving to part 5, Gate 4, Continuous operations.
Deploying to production must never be the end of your control. The perimeter defense never actually sleeps. SG4 monitors the live runtime environment continuously. Post-deployment, we're relying on tools like Amazon SageMaker Model Monitor to continuously check for data and model drift. We set up active latency and anomaly alerts, and we are constantly conducting ongoing access and IAM policy reviews to ensure there is zero drift in who actually has access to the production environment. Basically, SG4 converts runtime telemetry into continuous security evidence.
And finally, part 6, the human approval element. Okay, pause for a second. Despite all this massive, heavy automation we just talked about, guess who holds the final key? A human being. Automated scanners alone simply cannot push a model to production without a human explicitly badging them through. Specifically, this happens within the SageMaker model registry. The registry acts as this central control plane, and it completely pauses the promotion process until a designated human reviews the evidence and explicitly clicks approve.
So who exactly gets to hold these keys? Well, we require mandatory human sign-offs from a few distinct personas. The lead data scientist is a mandatory approver. They're in there reviewing the model KPIs against thresholds, checking the code, and making sure the data quality reports look solid. Then, especially for highly sensitive deployments, we bring in business analysts or product owners. Now, their job isn't to look at the Python code, right? Their job is to validate that the expected business outcomes are actually being met before those final doors swing open.
When you map this out, it builds so seamlessly into the AWS architecture. You'll see manual approval blocks nested right between the deployment to the dev CI/CD pipeline and the promotion to pre-prod and prod. The pipeline literally requests a manual approval by the lead data scientist using events like EventBridge. The approver checks the model registry status, reviews all that automated QA evidence we generated in the earlier gates, and only then do they allow the CI/CD pipeline to push the infrastructure out to the API gateway and Lambda functions. It is just a beautiful intersection of high-speed automation and strict human governance.
So, as we wrap up this explainer today, I want to leave you with one final thought. Your team might be incredibly fast at developing models, but if your pipeline's badge scanner fails close today, does your system automatically generate the SBOMs, the signed artifacts, and the test results needed to pass? Are you relying on hope, or are you relying on real, evidence-based promotion? It's a delicate but absolutely crucial balance to strike between release speed and impenetrable security. Thank you so much for joining me for Lesson 5. Keep building securely, and I'll see you in the next explainer.